Okay, so in this video, I'm going to teach you how to solve system of equations involving three variables. And we can see an example here on the screen, and we have negative x minus 5y minus 5z equals to 4x minus 5y plus 4z equals 19. X plus 5y minus z is equal to negative 20. When we solve systems of equations, we know that we want to find those specific x, the y, and z that will make the equations correct. Meaning to say, when you substitute the values, for example, in the first, when you put the x, y, and z, you get equals 2. And then when you put the x, the y, and the z on the second equation, it becomes 19. And when you put the x and the y and the z, it becomes negative 20. And these are specific values of x, y, and z that will make each or all these equations correct all at the same time. So how do we solve systems of equations involving three variables? The first thing that you have to do is to reduce the system of equations in just two variables. So meaning to say, initially eliminate one of the variables. It could be x, it could be y, or it could be the z. So how do you decide which variable to eliminate? To decide which variable to eliminate, you look at the whole set of equations and check which of the variables have coefficients which are closely related. So as you can see from the set of equations, if we look at the values or the coefficient on the y, we have negative 5y or minus 5y, we have minus 5y on the second, and a positive 5y on the third. So they're just the same numbers. It's very easy to eliminate when the numbers or the coefficients are the same. Okay, so in this case, I would say that the easiest to eliminate among the variables is the y. But that doesn't mean that you cannot choose the x or the z. You can actually eliminate x and z as well, but if we want to eliminate the easiest variable to eliminate, then it has to be the y in this case. Okay, so how do we proceed with eliminating the y? So keep in mind, our goal is to reduce the three equations into two variables only. So we have to eliminate one of them, and in this case, the best to eliminate is the y. So how do we proceed? So to proceed, you pick a pair of equations. It could be the first and the second, first and the third, or second and the third. It's up to you. But to make it systematic, you get the first and the second. Okay, so you pair up the first and the second. So we have negative x minus 5y minus 5z equals 2, and you have 4x minus 5y plus 4z equals 19. Again, remember, our goal is to eliminate the y. So to eliminate the y, we could either add or subtract the two equations, depending on which operation could eliminate the variable y. So in this case, we need to subtract the two equations. So performing the subtraction, so negative x minus 4x is minus 5x. Negative 5y minus negative means positive. So a negative 5y and a plus 5y will become 0. That is why the y will be eliminated. And then minus 5z minus 4z will be minus 9z, and 2 minus 19 is negative 17. So make sure that you perform the operation correctly. Okay, so after this, what you need to do is to take note of this equation and leave it for a while. Okay, then the next step would be to get another pair of equations, and we could use the second and the third, or first and the third. Again, it will be up to you. But to make it more systematic, we'll get the second and the third. Remember, we took the first and the second. Now we take the second and the third equations. So let's copy the second and the third. We have 4x minus 5y plus 4z equals 19, and x plus 5y minus z equals negative 20. And do not forget, the goal is to eliminate the y. So what operation can we apply? Is it addition or subtraction? It depends. If we look at the two equations, we will be able to eliminate the y if we will be adding them, because when you add a negative 5 and a positive 5, it becomes 0. So you have to add the two equations. So work on each term. So this will be 5x. This will now be 0. And then 4z minus z is 3z equals 19 plus negative 20 is negative 1. And then again, take note, this is our second equation. So as you can see, the result on the first and the second made the three equations reduce to just two variables, namely x and z. And this is just like a problem before in solving two equations involving two variables, that we just apply the process, solve for x or solve for z, and then that will help us to find all the variables eventually. Okay, so the next thing that we have to do now is to get these two equations, pair them up. So we have minus 5x minus 9z equals negative 17, 5x plus 3z equals negative 1. And it's up to you which variables to eliminate. So decide which is easier. Is it the x and the z? So for me, I see that it is easy to eliminate the x. Well, I could also eliminate the z by applying some operations, but by looking at it, we have a minus 5x or negative 5x and a 5x. Adding the two will eliminate the x. So we proceed by eliminating x. This will now be 0. A negative 5x plus 5x is 0. Negative 9z from minus 9z plus 3z, this will be negative 6z. And negative 17 minus 1 or plus negative 1 is negative 18. And then, solving for z, you have to divide by negative 6 on both sides. And z is negative 18 divided by negative 6 is positive 3. So, we were able to solve for one of the variables, x, y, and z. In this case, we have the z value. So once you have one of the values for the variables, it will now be easy to get the other two. What you need to do is to just go back to the equations that we had. So from this pair, so these two, you select which of the two you would like to use the z, because you already know the z. So let's select minus 5x minus 9z equals negative 17. So we have minus 5x, negative 5x, minus 9z equals negative 17. And by the way, you could also use the other equation if you want to. Okay, so now that we know that z is 3, then all you have to do is to substitute that value on the equation negative 5x minus 9z equals negative 17. So we have negative 5x minus 9, z is 3, equals negative 17. And then solving for x, you have negative 5x minus 27, that's 9 times 3, equals negative 17. And then negative 5x equals negative 17 plus 27 by adding 27 on both sides. And then negative 5x is equal to positive 10. That's 10. 27 minus 17, or negative 17 plus 27. Therefore, x is equal to, so when you divide both sides by negative 5, x must be equal to negative 2. Okay, so we're almost done. We now found the value for x. Remember, z is 3. We found that earlier. And then x is negative 2. And what is left to find is the value of y. So how do we find the value of y? You go back to the system of equations, and then you pick from the three equations. It's up to you. It could be the first, the second, or the third. It doesn't matter. Well, it matters when you want to make it faster. Okay, so working on the first, we have negative x minus 5y minus 5z equals 2. So we'll get that equation. So we have, so in our equation we have negative x minus 5y minus 5z is equal to positive 2. So this is the first equation in the systems of equations. So negative x minus 5y minus 5z equals positive 2. Okay, so now all you have to do is to supply the values of z and x on the equation. So this becomes negative of negative 2. Make sure to substitute properly. Minus 5 times y. Well, we still don't know the y. Minus 5 times z, which is 3, equals 2. Then just work on this equation. You have positive 2 minus 5y minus 15 equals 2. This becomes negative 5y, and the 2 minus 15 becomes negative 13, or minus 13, equals 2. And then minus 5y, if you add 13 on both sides, then you have 0, but the other side becomes 15. And finally, if you divide by negative 5, dividing by negative 5 will give you y equals negative 3. So the value of y is equal to negative 3. So to write all the solutions, we have x equals negative 2, y equals negative 3, and z equals positive 3. Or in other form, you have negative 2 as your x, negative 3 as the y, and positive 3 for the z. So you can write it as a point. Okay, now you could also, so what you can do in addition is to make sure that these values are correct. So to check if the values are correct, what you have to do is to substitute it, or substitute them on the three equations. And if you will get 2 on the first, 19 on the second, and negative 20 on the third, then that means the values are correct. Okay, so that's an optional check whether your answers are correct. Show the checking. So from the first, we have negative x. What you have to do is to substitute the values. We have negative of negative 2 minus 5 times negative 3 minus 5 times 3, and check what will be the outcome. Okay, so this is 2, this is 15, and then this is minus 15. If you have 2 plus 15 minus 15, that's equals 2. So meaning to say, it's correct. Then you do the same for the second equation. You have 4 times negative 2 and then minus 5 times negative 3 plus 4 times positive 3, and you check if the outcome will be 19. This is 8, so this is negative 8, and then 15, negative 5 or minus 5 times negative 3, and then the 12. Negative 8 plus 15 is 7, plus 12 is 19, so it's also correct. And finally, you check on the third equation, you have negative 2 plus 5 times negative 3 minus positive 3, because it is z equals 3, and you check if the outcome will be negative 20. So negative 2 plus 5 times negative 3 is negative 15, and then minus 3. Negative 2 minus 15 is negative 17, and a minus 3 again is negative 20. So that means it is also correct. So we have solved the system of equations with x equals negative 2, y equals negative 3, and z equals positive 3. Okay, so to summarize the process, because it seems to be a very long process, but you know, the reason that it took us some time because I was explaining the details on how to solve the system of equations. But to summarize, remember the key idea is, so from here, the first thing that you have to note or to do is reduce the equation into two variables. And if you remember, we decided to reduce it by eliminating the y. Then from there, you perform, because you reduce it into two variables, perform solving equations in two variables. That's what we did with these two equations. And once you do that, you'll get one of the values, that is in this case the z, and then work backwards. So work backwards to find the x, and that is, we went to one of the equations, minus 5x minus 9z equals negative 17. We substituted the z, and eventually that led us to, or in finding, the value for the x. And once you have the two variables, again work backwards by going back to the given problem and select whether it is the first, the second, or the third to use when substituting the x and the z to eventually find the y. And from there, you can have the optional check by substituting the values of x, y, and z to know if your answers are correct. Okay, so I hope this video will be able to help you, or was able to help you in understanding how to solve systems of equations involving three variables. So I'll try to create more videos on this, showing how the process will be applied in some other cases. Okay, so that's it. Thank you.